Hello everybody, this is Mr. Bowman. So today we're going to wrap up with angle addition and angle bisectors. So this is pretty similar to, say, segment addition and some of this stuff, but we do get some slightly different scenarios out of this. So if you remember from segment addition, we had a little piece plus a little piece that equaled a big piece. Same idea. We're going to have a smaller angle, which if I put it directly next to, so these line up and they're shared, another angle, so I can have angle 1 and angle 2. I get a large angle here. Okay, that's angle addition. So say we have one that comes like this. Same idea as when we had segment addition. If this is, I don't know, it's actually pretty big, 80 degrees, say. And this one looks like it's probably closer to 60 degrees. Then when I add these together, I end up with a large angle of 140 degrees, or 80 degrees plus 60 degrees, right? So that's angle addition in a nutshell. It's not too crazy. I'm sure you'll be able to handle that. But there are a couple special cases that do happen here, and that's what happens if I add together and get... They're special numbers, but we're not really going to get into why they're special at the moment. Okay, so just bear with me. What happens if I have ones that make right angles? Okay, so if I get a right angle, so maybe I add together, let's make this easy, call it a 6-degree angle and a 30-degree angle. So 30 plus 60 does give me 90, so that makes this whole thing a right angle. These are known as complementary angles. Okay, or you can say 30 is the complement of 60 and vice versa. Our other special case is what happens if we have angles maybe like this one and this one. So if I have, let's call this 30 degrees again, and I call this one 150. They add up to a straight line, which is 180 degrees. These are known as supplementary angles. Okay, so those will come up. Sometimes it's directly, and you'll say things like, what's the complement of 60? And you'll say 30, because it's just 90 minus 60, or supplement of 150, whatever. So sometimes they come up directly. Sometimes they're a little trickier than that, and they're not as straightforward. For example, sometimes you make an equation out of them. Okay, so what I mean by that is sometimes, let's say I have a set of complementary angles here. We'll call them angles 1 and 2. If I know that the measure of angle 1, so remember that measure there means it's going to be a set of degrees or something like that. So the measure of angle 1 is, let's call it 2x. And the measure of angle 2 is x plus 40, say. Okay. Then, can I figure out how big each of those angles are? And I can, because I know these are complementary, so they add up to 90. So what I can do is say 2x plus x plus 40 equals 90. And I can just solve like normal. So I end up with 3x plus 40 equals 90. Subtract that off. 3x equals 50. Divide by 3. Not going to come out nicely, but that's okay. So what do we get here? And we're going to have to round that, and that's okay. So, let's see, 50 divided by 3 ends up with about 16.7. Now notice I'm not directly putting degrees on this number. It's a little finicky when you do that. If I'm being super technical, I actually should have them up here. So, because they measure, so they should be in degrees there. So I'm going to actually plug this number back in to figure out my actual degrees to finish this one up. So it would be 16.7 times 2, which should end up at 33.4, unless I'm much mistaken. And the measure of angle 2 is 16.7 plus 40. So I end up with 56.7. Yep. All right. And then you do want to double check to make sure these actually come out to 90 degrees. And you'll see why here in a second. So if I add this up, I end up with 89.1, so 90.1. So there is a little bit off there because of my rounding error. So when I rounded this from 16.66667 up to 0.7, so that does throw it off a little bit. So you can adjust one of these down. And I think since this was my smaller one, I think I'll do it here. Or you can leave it, it depends. But usually it says where to round something to. And if you round here, that's usually where this goes wrong. So if you don't round here or round further down, you're going to have less of an issue when you get over here. So, but anyway, these should add up to 90. So I'm going to just adjust this one to there so it comes out. Okay. So that is how you might use those complementary and supplementary definitions. Okay. All right, and one last thing to show you here is what if we have an angle bisector? What exactly does that mean? So if you have an angle bisector, this is not as crazy as it sounds. And this kind of looks like a right angle, but it doesn't really matter, so I'm going to ignore that. An angle bisector literally means bisect, which means two pieces. Okay, so I'm going to cut it exactly in half. So if I have, let's name this. So I could say that BD, and this could be named as a ray or a line segment, when some people flip back and forth on that. It doesn't make a whole lot of difference. So I could say that BD bisects angle ADC if these two are equal. So in order for me to say this, I either have to know these measurements or I'd have to get it from some other thing, but I have to know they're exactly the same. So what I could do is if I know this one is 40 degrees and this one's 40 degrees, then I could say this. So they have to, it means it cuts it exactly in half, which if you know it bisects, you can make a couple helpful conclusions because it's almost symmetrical. So if I know that this one bisects this angle, and I know this is 25 degrees, I know this has to also be 25. So if you know things about bisecting, you can usually cut your math you have to do in half, which is always helpful.